It's Matd1534. We're busy with unit 12, and this morning we're going to look at even and odd functions. Okay, now please be warned that some people get confused here between the symmetry, the test for symmetry, and the test for even and odd. So please watch the question and read it properly in the exam or in a test or something, that you know exactly what is asked. So if you understand the test for symmetry, this will be very easy for you. So when you do the test for even and odd, you just look at f of negative x. In other words, you look at symmetry in the y-axis. And if a graph is symmetrical in the y-axis, it will be an even function. So this is actually very, very easy. So just don't get confused with the test for symmetry. Here you just do f of negative x. F of negative x. In other words, you swap x for negative x, and you check if you get the same answer. When you find the same answer, it is even. When you get negative the original, it is odd. And when you, of course, get none of the two, then it's not even and also not odd. So we're going to do examples you'll see now. But I just want to focus your attention upon that you are actually testing for symmetry in the y-axis and also in the x-axis for the negative one. So then it's odd, and in the y-axis it's even. Here you can see in diagram number 1 here, this is even. So it's symmetrical in the y-axis, so it's even. And then odd means you get negative the original back. So and then yeah, you're not going to get even or odd. But remember, we're going to ask it in a algebraic way, like this example again. So we have to focus on this example. So the question will be exactly as it is here. Determine whether this is even, odd, or neither. So what you do is you take the function and you swap the x for negative x. So we swap the x for negative x. We just work it out. Be careful, keep brackets. I want you also in the symmetry to use your brackets. Be careful for all these negative signs and then see what happens. Well, I can clearly see that is not the same as that. So it's not even, because I must get the same answer back for even. But if I take out a negative here, I see, okay, I am getting negative the original. It's negative the original. And because I'm getting negative the original, this is an odd function. So really not difficult. Okay, let us look at an example, another example quickly. So let's say we have this number 2. We take number 2 here. So we have f of x is x and x minus 1. You can multiply it out if it's going to be easier for you, of course. X squared minus x, that you just know this is the original now. This is what the original looked like. So now we work out f of negative x. So it's negative x squared. You see, I'm going to use my brackets, minus negative x. Okay, so now I'm just checking what is happening. I'm getting x squared plus x. Well, that is not the original. It's not the original. The original is x squared minus x. And if I take out a negative here, I'm going to get negative x squared, negative x. But that is also not negative the original, because I should have had positive x squared here. So this is not even, this is not odd, this is neither. So this function is not even, and it's also not odd, it is neither. Okay, It's not even, it's not odd. It is neither of the two. All right, let's do one more example. Let's do number 4. Okay, I've got f of x is x, and then x squared plus 1. Okay, I'm going to multiply it out again that I can see what the original looked like. It's x to the 3 plus x. So that's my original. Now I need to see whether this function is even, odd, or neither. So I'm doing f of negative x. Doing f of negative x. It's giving me negative x in brackets. Please use brackets. Plus negative x. And I see this is minus x3 minus x. Well, this is not the original. But if I take out a negative here, I do get negative the original. This is definitely negative the original. So this function is odd. It's an odd function. Okay, so for interest's sake, the sine graph is odd because, yeah, let me show it as an example. Because that's where we use it the most actually. Okay, so say now I have y is sine x. And I swap it now for negative x. Let me rather do f again. Okay, I'm just going to change this to I just want to make it f rather. So let's say f of x is sine x. You see now if you do f of negative x, you see this is the sine of negative x. And we know that the sine of negative x is negative the sine of x, which is negative the original, so this is odd. And if we do y is cos x, okay, now I did y again, but it doesn't matter. And now I swap the x for negative x. We know that the cos of negative x is exactly the same as the cos of x. So this is even. So cos is even and sine is odd. Cos is an even function, sine is an odd function. All right. So these are now then to see whether a function is even, odd, or neither.